All right, so then we can form up bigger statements, right? And I put in the brackets here, but normally we won't put in the brackets, right? I put in some brackets between ands and exists and stuff, but here, this one you should know. All right? This is a statement about girls, right? The girls is on the outside. It says there exists a girl that has a certain property. What's the property that she has? It's the property that all boys love her. All right? Right? So you can think about a program that finds out if this is true. It loops over all girls until it finds a girl that has the said property, right? And what's the said property? Well, it loops over all boys, seeing if all the boys have the said property, right? Which is the boy loves the girl. Everybody see this little code? Right? And here, it's true, right? You search over all girls, you find this girl. For that girl, you search over all boys, and you get true, right? All right, so what about this one? Is there a girl that is loved by all boys? No, right? Everybody see that? All right, so now we do a different one. See if we can get rid of this thing that you know I hate. All right, now, this is no longer a statement about girls. It's a statement about boys. It says what? It says every boy has a particular property. What's that property? Is that he loves somebody, right? So we loop over boys, looking for a boy, looking to see if they all have the property, right? And for each boy, we look over and see if there's some girl that he loves. And all right, so is that true in this one? Does every boy love somebody? Yeah, every boy loves, in fact, everybody loves Marilyn Monroe, right? What about in this one? Is it true in this one? Yes, right? Everybody see this? All right, here is the same thing with ands and ors, right? Here we're saying, what does this say? This says, this boy loves G, and this boy loves G, and this boy loves G, and this boy loves G. This is saying all the boys are loving this particular G, right? And what is this saying? This is saying this G is loved by all boys, or this G is, or this G is, or this G is, right? Yeah?
So when we talk about proving things that exist, it's really like more proof by case, like scenario, because you just say.
Yeah. So I'm kind of showing you this slide and assuming something is true that's not true in general, which is that we have a finite number of objects, right? So here, I'm only able to construct this because there are a finite number of girls and boys, right? As soon as we're doing the integers, this gets a little harder, right? So, yeah, right? Everybody see this? Well, here we're saying all boys have the property. What property? That there exists that one of the girls he loves, right? Everybody get or and and here? All right. Now, what motivated me to teach this course is I kept hearing that people weren't liking what George does, and I was teaching 2001 for decades, and people just did not understand Forall that exists, all right? And the big thing they were getting wrong is there's a difference between saying there exists the boy for all girls, and for all girls there exists the boy, right? We just saw on there that they have different code, so they're different, right? And you need to deeply in your soul know that they're different, all right? So here are various scenarios of love, and Now let's look at some English statements, right? In all three, every boy loves a girl, right? You can see that's true in all cases, right? But what's the difference between these cases? Right? What's true? What makes this one kind of special? They all like the same girl, right? It's all one girl. And here it's various different girls, and you have a little polyamory happening, right? And this is one unique girl for each boy, right? The Pope is happy. Everybody see? All right, so here we can say, how are we going to say this in English, right? We could say, there is a girl for all boys to love, right? There is a girl for all boys to love, right? So that feels like that one, right? And what's this? For each boy, there's a girl, right? Now, okay, for which of these three is this sentence true? Right? It's just true for the first one, right? And which of these three is this one true? Right? They're all true, right? All right, so here's I'm just taking the words and writing them down exactly the same. All right? There is an inverse, exactly 1/3, right? What is the inverse of 3? 1/3 is the multiplicative inverse of 3. So there is an inverse for all reals, right? That's a perfectly good sentence, except for 0. Let's not get into that, right? Now, what's the problem with that? Is you would say both of these as an English sentence, but this one, you're kind of meaning that it's the same girl. And here, well, no. 3 has the inverse of 1/3, and 4 has the inverse of a 4. They all have different inverses, right? And why am I telling you this? Is don't rely on English. Because English doesn't do the trick. Right? You hear what I'm saying? Now, similarly, let's go down here. For each person, there is God, right? Now, it depends on what religion you are in. I thought everybody knew basic religion, so I had something on the test where the answer was every Hindu has different gods, but every Christian has the same God, and everybody complained they didn't know enough religion to do that. But here, if we're living in our Christian world, then it's all the same God, right? Here we're saying for each person, there's God. For each boy, there's a girl. It's really looking, it's the same sentence, but it's the other one. Hear what I'm saying? So don't trust English. All right. And so now we're going to be writing it down in math because the math is better, right? It's clear. And what is this saying? Right? This is saying, as I've said already, this says there exists one girl that has the property that all boys love her, right? Well, this one says, it's a statement about boys. It says every boy has the property that he loves some girl, right? Everybody get that? All right. Now, one of the many things that George got upset with me about is I think about this sentence as a function, right? Why is it a function? It says every boy, for every boy, there's a girl. How would I prove that? Well, you give me a boy. It says it's true for every boy. You give me some boy, Sam. Now I need to prove that Sam loves somebody. How do I do it? I say, look, Sam loves Beth, right? Fred. Fred is a boy. It's true for all boys. there needs to be a girl. Who does Fred love? Fred loves Anne, right? Everybody see how we got a function here? From what does this say? It says, in some ways, it says the existence of a function that takes in the boy and returns a girl that he loves, right? Yes.
It's not necessarily a one-to-one.
No. In fact, we're gonna understand these. We're later gonna look at functions and properties of functions and see what these say about the function, right? Now, I'm not saying anything. In fact, all I'm saying is that there's a function that's well defined on every boy. For every boy. In fact, there could be John may love many girls, right? In which case, this function could return one of them, right? Or you could, yeah, let's not get into weird things. All right, so there. All right, now we're gonna be proving things, and we're gonna have various levels of formality about that. But my goal, George said intuition is bad, and I so disagree. What I want to give you is intuition, right? So you should know that the first proves the second, right? Any universe in which A is true, B is true, right? Anybody want to get a go at proving? Let's assume we know A is true, right? If A is true, then there exists a girl, say Marilyn Monroe, that every boy loves. All right? Now, how do you prove B? Every boy loves some girl. How do you prove that?
Because every boy loves me.
Every boy loves Marilyn Monroe, right? Everybody see that? In fact, I would play the game. For every boy, okay, give me an arbitrary boy. Exists, I need to construct the boy that he loves. He loves Marilyn Monroe. Done, right? So, real informally, right? If there's one girl that every boy loves, then every boy loves at least that girl, right? Proof. All right. So that's, I made these slides about this election. We're coming up to different elections, but it's good to know what these statements mean, right? We could put Trump in here, right? What does this say? This says there exists one politician, right, that every voter loves. Now, see here? This is saying there's a politician that every voter loves. And is that true in any universe you've ever been to? No, right? But this one down here is this one's not even true, right? Have you heard the expression, the problem with elections is that the government always gets in, right? You might not like any of the politicians, right? But this is claiming for every voter, there's some politician that he loves, right? This one's a statement about politicians, right? There is a politician that's loved by everybody. And this is a statement about voters. Every voter loves somebody, right? Everybody get that? All right, so he was talking about functions. This statement says, for every X, there is a Y, right? Is that true here? Well, assuming it goes on forever. Yeah, right? It's just, all it's saying is that F is a function defined on the whole domain, right? If you took 1019, which you should have, you should know this, right? What does this one say? All right, so yeah, let me tell you right now, if I ever ask you to explain what a line means, you gotta do a little more than read it, right? So if you just read, what does this mean? Well, it means that there exists a y that's for all x, right? You gotta somehow give me something that you get it, right? And what does it mean? There exists one y, right? What? Yeah, it's what? So what did you say?
It's saying that there's a y exist and all exist.
Yeah.
All exist goes that y.
Exactly. Exactly. And so what does it say about the function? It says that it's constant, right? This says there exists some value y, and I don't care what x you give to me. F of x is constant, right? This is talking about functions. All right. So if you haven't seen Clockwork Orange, my story is that it's not so scary now because they make scarier movies. But in my day, I read the book, then watched the movie, and it was scary in my day. All right. So this is where if you ever say something, certainly if you're in my 2001 class, then we got to punish you. All right. So here's the statement that people say. All right. They say for every input, right? I want to argue that computational problem P is computable, right? And how is it computed? It's computed by some Java program, right? So I could say for every input, there's a Java program that solves the problem, right? How do you feel about this? Do you feel pain in your body? Why?
It's not happening. Not always.
All right, you don't feel pain yet, right? So that's why, in fact, what happens in the movie, they hold his eyes open and they teach him to respond to certain things with pain. All right. So that's what I'm doing here. I want to teach you pain. All right. So here we have a problem P. What does it do? For every input, it says what the output is. So there's a really nice problem. You give it x, it gives you x squared. Right? Is it computable? Yeah. Now, what does this statement says? We want to say that there's a Java program that solves it on every input, right? In fact, here's a Java program, right? Everybody see the Java program? Take the value of x, you return x squared. The Java program, it computes x squared. Agreed? Right? It's one program, right? Now, what is this saying? Is this saying what we want? Does it say there exists one program? No, it doesn't. It doesn't. It says for every input. For every input, there exists a Java program, right? So what it's saying right here, this is a perfectly good Java program that works for 3, right? This right here, I'm proving that for every input, there's a Java program. And it could be a Java program for a different Java program for every input, right? And that's bad. You know what I'm saying? As a computer, so you agree that as a computer science person, you should feel pain when you see this sentence, right? Now, the halting problem, if P was the halting problem, it's false that the halting problem is computable. Why? Because there doesn't exist one program that solves it on all inputs. But is this sentence true? Absolutely, it's true. For every input, the Java program, the halting problem either says yes or no. So there's a program that just says yes or no, and one of them works, right? So So what do we say instead? We say there exists one Java program that works for every input, right? It's a much stronger statement, right? Is everybody good?